All right, so in this problem, it says an electric field with a magnitude of 378 newtons per coulomb exists at a spot that's 0.4 meters away from a charge. So let's make a charge. So we have a charge, and now we don't need another charge for there to be an electric field. All we need is a location from that charge. So they're saying at this location, so let's say that's the location, there's going to be an electric field, and that location is 0.4 meters away. Now we know what the electric field is at that location away. We know that the electric field is, now again, I'm just assuming the charge is positive so that the electric field is away from it. If it was a negative charge, then it would be towards it, but it would still be the same magnitude. So we know that the value here, if you look at the problem, it's 378 newtons per coulomb. Now, I want to know what the electric field is if I'm 1.6 meters away. Now, the thing is, 1.6 meters away is exactly 4 times 0.4. So you could actually do it based on, we have a formula for electric field that says E equals KQ over R squared. So I know that E varies with the inverse of the distance squared. So if you double R, you should get what fraction of E? If I double R, double the distance, like the double is being squared, what fraction of E will I get? Yep. 1/4, right. If I triple it, I would get what? 1/9. If I quadruple it, 1/16. So actually, this is quadrupling it. But I don't want you to think, oh, well, I'll just do it that way, because it works because 1.6 meters is exactly 4 times 0.4. But what if the number was 1.5 or 1.3 or 1.7? It would not then be exactly 2, 3, or 4 times bigger than the other one. So I need another one.
This happens to be like convenient enough for us to do it.
Right, in this problem it is, but I want you to be able to solve every problem, not just the one where it's exactly twice as big or 3 times as big. Okay, so I know this, and I'm looking for the electric field. So if that's, let's see, that's 0.4, 0.8. So way out here, we're going to have an electric field out here. Now I know it's going to be smaller. So I'm going to make a smaller. One of you guys is going to be moving. So.
I'm sitting by myself.
Yeah. Right here. Okay, so what I want to know is, what's the electric field here? So if I call this E1, let's just call, because I'm going to give it a name. If I call that the electric field at position 1, you can call it the original and the final, or whatever you want that helps describe it. But that's the electric field at 1. And I want to know, well, then what's the electric field here? I know the units are going to be newtons per coulomb. So I'm going to show you a couple of ways to do it. I'll show you the way that most don't choose to do it first, and then I'll show you the way that most do choose to do it. So if this is my equation, I now that's what E1 is. Okay, so I know it's based on the R1. So if I call this, so this distance right here is going to be R1. This distance right there is going to be my R2, which I also know that value. I know it's 1.6 meters. So what I want to do is, I know that the electric field there is going to be still the same K, the same Q, but it's going to be a different R. So right now, I know that I know what the value is when it's R1. So what I'm going to do is I'm going to do it like I'm doing a conversion. Is a conversion, I would do this. I'm going to say, okay, that's R1. Extend my line and go from R1 squared to R2 squared. All right? Because if I do this, the R1 squareds will cancel out, and I'll get the R1s will cancel out, and I'll get KQ over R2 squared, which I know is the electric field right there. And I actually know what this is. So this is 378. So all I have to do is take the value 378 and multiply it by this fraction, and I'll get what the value is at 2. So this is going to be, let me put an E2 in here, because that's now what equals E2. But this, right there, that's E1. So we know so this is E1. So I'm basically taking E1, multiplying it by the distance for 1 squared, and dividing it by the distance of 2 squared. So putting those numbers in, I'm going to get 378 newtons per coulomb, and then I'm going to multiply it by the fraction, 0.4 meters squared divided by 1.6 meters squared. All right? And if I do that, I'm going to get my answer for that. This is one way of doing it, and then I'm going to show you another way that I think most people like the second way. But I figured I'd show you this way first, and then see if you like the other way. A lot of times, whatever the first way is that you learn, that's usually people feel comfortable with it. But I figured I'd give you what most people think is the easier way is the one I'm not showing right now. So if you do this, you're going to get what? So basically, this thing, I know that this number happens to be 4 times bigger than that. So it's as if it's 1/4, but because of the square, 1 squared over 4 squared. So whatever that number is, divided by 16. So hold on 1 second. So that answer should be 23.6 newtons per coulomb, which must be 378 divided by 16. You have a question?
Yeah, why is 0.4 meters squared in the numerator if it cancels out with 0.4 squared in the denominator?
Well, that's why it's in the numerator, because this right here is 0. So in solving for E1, okay, so in solving for E1 equals KQ over R1 squared. So I want to get rid of R1 squared because E2 does not equal KQ over R1 squared. It equals KQ over R2 squared. So just like anytime I do any conversion, whatever I'm trying to get rid of goes on the opposite side of the fraction line in the next fraction down. So I want to get rid of this, so I get rid of it and replace it with that.
Yeah, so
Well, that's what I did. This is R1. R1 is 0.4. That's R1. R2 is 1.6. Okay, so now that we did it that way, this is another way of doing the same problem. If you look at the original problem, I'll do it in a different color here. So if you look at the original problem, we know that E1 equals KQ over R1 squared. So we know that. I already know what E is, I know what R is, and I know what K is. So really, the only thing I don't know is Q. So let me rearrange this formula to solve for Q, and then that's going to be the same Q that I could then plug into the formula E2 equals KQ over R2 squared. I can just do that. So let's now solve for Q. So Q is going to be E1 R1 squared over K. So that's going to be 378 newtons per coulomb times 0.4 meters squared divided by 9 times 10 to the 9th Newton meters squared per coulomb squared. And what do you get if you solve that? And notice the units will be coulombs because the Newton will cancel the Newton, the meter squared will cancel the meter squared, And one of the coulombs will cancel one of the coulombs, but I'll still have 1 coulomb left in the denominator of the denominator. So what do you get for that? That this is going to be like the source of our electric field, the source charge. 6.72 times 10 to the negative 9 coulombs. So that is my Q. So now that I know the Q, I'm just going to now plug it into this formula, but solve for E2 instead of E1. So I'm going to get E2 is going to equal KQ over R2 squared. So I'm going to put in KQ over R2 squared. So for K, 9 times 10 to the 9th Newton meters squared per coulomb squared. For Q, we just solved for Q. 6.72 times 10 times 10 to the negative 9 coulombs. And the distance, so the only thing that's changing is instead of us being 0.4 meters away, the new electric field is going to be when we're 1.6 meters away. So if you solve that, I hope you get 23.6 newtons per coulomb, because I should get the same answer I got by doing it the other way. So now it's up to you. Do you prefer to first solve for the charge, and then with the charge that you know, the charge doesn't change, I'm just moving a different distance away from it, plug into the formula for electric field with the new distance and solve for the new electric field. Or do it like a conversion. I mean, this is really, the top one up here is like doing it like a conversion, because I know this right here equals E1, so the only difference between E1 and E2 is that should be an R2 squared. So I get rid of that and replace it. So whatever way is easier for you. Actually, I would say probably this way is a one-step way of doing it. This way is 2 steps, because I first have to get Q and then plug it in. But for some reason, my students in the past have preferred doing it this way than doing it that way. Whichever way works for you is fine with me.